So this is the linear graphical analysis file that you will have access to just below. I just want to quickly go through what's happening. And so you see there's a yellow line. The yellow line says position of the yellow, and then the blue line says position of the green card. If you click on this, you'll see there's dataset 1, 2, 3, and 4. The experiments that worked well were dataset 2 and 4. We're talking about dataset 2 only at this point. You'll see that this yellow line is going downwards. You'll see that initially, if I was to zoom in on the first part of the graph, that it was a curve. So it's curving here. That means it was pushed and it's accelerating. So that means I'm actually touching the cart during that first kind of, I don't know, 0.18, it was 0.18 seconds. I'm actually physically touching the cart as it's accelerating, and then from about 0.3 seconds down to a 1.78 seconds, it's basically traveling at a constant speed. And so we can highlight the data that we want to look at, come down to this button here and go apply curve fit and go linear. Now you'll see that it's got this crazy blue line and a nice yellow line. And so you'll see that it has the gradient 0.2837, and you can see that I can move where I'm measuring. And basically that 0.28 number doesn't change because it's still a straight line. But as I change this position, it's trying to average the blue line, which is between 0 and 1.6 seconds. And you can see that something changes for the blue line at about 1.34 seconds. So for the first 1.34 seconds, the blue line, which is the green cart, wasn't moving, but the yellow cart was. And so that's why there's a little bit of confusion potentially there. And then when I look at the next part of the graph, we see that the blue cart did start to move, and I can get the blue line green cart did start to move, and so it's about 0.9 of a second. And if we were to zoom in on this part of the graph, we would see that there's a bit of a curve, and so while the spring was engaged, it was accelerating. And so we need to be careful about what part of the graph that we're talking about, and you don't want to go too far, because now you see this blue line doesn't represent this bit here. It represents this from 1.4 to 1.6 seconds, but it's also representing from the collision point, which is at 1.78 onwards. And so you've got to be quite careful about which bit of the data you're collecting. At about 1.78 seconds, you can see that the yellow graph, and so the yellow and the blue lines, they change, and then they basically begin to track or follow each other. You'd expect, if we highlighted from there onwards, to be a straight line. And if we apply a curve fit to both of them, you see that they don't perfectly follow that line, and actually there's quite a bit of deviation, and that's saying that it's deaccelerating, and it's deaccelerating because there's friction in the track. And so we can really only talk about initially after the collision, because we're assuming that momentum is conserved, and we would expect both of these numbers, the 0.1357 and 0.1389, to be exactly the same, because the carts are connected to each other, and so they should be traveling at the same speed. And so I think there's some sort of calibration error happening there, and in the next part of the video I talk through how we might deal with that. But I wanted you to understand this, because what you're going to do is you're going to look at dataset 4, and so you can turn dataset 4 on and turn dataset 2 off, and then you can do some of that analysis there.